probability. A probability is the likelihood of an event occurring. Probability lies between 0 and 1 inclusive. A probability of 0 indicates that the event is not likely to occur, while a probability of 1 indicates that the event is extremely likely to occur. Probabilities can be expressed as a fraction, a decimal, or a percentage. For example, probability can be written as 1 over 2, a half, or 0.5, or 50%. It's a good thing to be able to use the fractions function on your calculator in order to do these probability problems. Here is a sample calculator just to indicate where the fractions, what the fraction function would look like. I'd also point out that this calculator has other functions. Here it has e to the x. That's a function that we will use in Unit 6. Right, so your calculator should have most of these functions. Another one, x to the y, to be raised some number to a power. Right, those functions we'll be using in the next unit. All right, let's continue looking on probability. We're going to look on some definitions of terms as they would be used in the unit probability. An experiment. Now, in probability, an experiment is an activity that is either observed or measured, such as tossing a coin or drawing a card. Okay, that's an event. That's an experiment. Then we're going to look on an event or an outcome. This is a possible outcome of an experiment. For example, if the experiment is to sample 6 lamps coming off a production line, an event could be to get 1 defective lamp. Another event could be to get 5 good ones. All right. So the experiment is selecting 6 lamps, and therefore the event or the outcome is getting 1 defective lamp and 5 good lamps. All right. Now the sample space is a complete set of all events of an experiment. So the sample space of rolling a die is 1, 2, 3, 4, 5, and 6. Right? Those are all the possible events or all the possible outcomes when you roll a die. The sum of the probabilities of all the possible events of an experiment is equal to 1. In other words, when you roll a die, have we said just now, all the possible outcomes would be 1, 2, 3, 4, 5, and 6. Now the probability of getting a score of 1 is 1 over 6. The probability of getting a score of 2 is 1 over 6. Probability of getting a score of 3 is 1 over 6, etc. Now when you sum all those probabilities, it must be equal to 1. And this is so for all experiments. Now a simple formula for finding probability. The probability of an event, I'm just using E. You can use a capital letter to summarize the event. So the probability of an event E is equal to the number of favorable outcomes over the total number of possible outcomes. The number of favorable outcomes over the total number of possible outcomes. And we're going to look on an example here. A biostatistician employed by a hospital classified patients who had surgery during a 9-month period by age, in terms of years, and the type of surgery risk. She classified a total of 190 patients. So this shows that there were 8 patients who were under the age of 16 and had low-risk surgery. There were 21 patients between 16 and 45 who had low-risk surgery. Right? Another example here would be 41. These 41 patients who were over 45 and had high-risk surgery. Now, what is the probability that a randomly selected patient had a high-risk surgery? Now, on the previous slide, we said probability is the number of favorable outcomes over the total number of possible outcomes. Right? Now, what are the number of favorable outcomes? What's the probability that a randomly selected patient had a medium risk surgery? So we're looking for medium risk surgery. How many medium risk surgeries were performed. And from the table, we can see that it will be 59 medium risk surgery out of a total of 190 patients, right? What is the probability that a randomly selected patient? So we're looking at all 190 patients. So our denominator is going to be 190. And we're looking for the events that medium risk surgery, and that is 59. So the answer would be 59 over 190. Okay, another question. What is the probability that a patient had a medium risk surgery and is at least 16 years? Medium risk surgery and is at least 16 years. At least 16 years mean that the patient is 16 years or more. All right. So what's the probability that a patient? So we're looking at all the patients. So the denominator is going to be 190. Now, how many of these patients had a medium risk surgery and is at least 16 years? Okay, we see here where there were 13 patients under 16 who had medium risk surgery, 9 between 16 and 45 who had medium risk surgery, and 37 who were over 45 with medium risk surgery. So how many of these patients had medium risk surgery and is at least 16 years? That would be our favorable outcome. Okay, and we realize that we would have to sum the 9 and the 37 to find the total number of patients who were at least 16 years and had medium risk surgery. So that would give us 46 over our 190 patients. And that can be broken down to 23 over 95. All right, we're going to move on now to one of the rules in probability, the addition rule. Now, the addition rule states that if you want to find the probability of one event occurring or another event occurring, this is equal to the probability of the first event plus the probability of the second event occurring minus the probability of both events occurring at the same time. Okay, so the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B occurring at the same time. So we're going to look on an example here. What is the probability that a patient had a high risk surgery or is over 45? So when you see that or, we have one event, a high risk surgery, or, and then another event is over 45 years. So it indicates to us that we will have to use the addition rule. So we need to find the probability of A or B, probability of a high risk surgery or is over 45. That will be equal to the probability that the patient had a high risk surgery plus the probability that the patient is over 45 years minus the probability that the patient had a high risk surgery and is over 45 years. Okay? From the table, we can see that 75 patients had a high risk surgery, so that will give us 75 over 190. Probability that the patient is over 45 years is 105 over 190. And the probability that the patient had a high risk surgery and is over 45 years is 41 over 190. All right, so we can put that in the formula. Probability of high risk surgery or patient over 45 is the probability of a high risk plus the probability the patient is over 45 minus the probability of the patient has a high risk surgery and is over 45 years. Okay, this works out to be 139 over 190. Notice the denominator is the same throughout. In the addition rule, the denominator is going to be the same for each of these three terms. Okay. Now we're going to move on to look on mutually exclusive events. Now, mutually exclusive events are events that cannot occur together. All right, events that cannot occur together. So when we look again at the addition rule, the probability of A and B would be 0 because they cannot occur together. Right, so when the two events cannot occur together, it's referred to as mutually exclusive events. For example, the probability of tossing a coin and getting a head and a tail at the same time, right? That doesn't happen. So those two events cannot occur at the same time, so it will be referred to as mutually exclusive events. And if we look on the same question, list two events that are mutually exclusive. One would be the patient cannot have a low-risk surgery and a medium-risk surgery at the same time. It's either low risk or medium risk. Okay. Similarly, the patient cannot have a low risk and a high risk surgery at the same time. All right. The patient cannot be under 16 and over 45 at the same time. Okay. So there are quite a number of mutually exclusive events that we can find from that table. Are the events high risk surgery and over 45? Are these events mutually exclusive? Give a reason for your answer. Now, if they are mutually exclusive, it means that the probability that the patient had a high risk surgery and is over 45 years, that probability would be equal to 0. But from the table, we know that the probability of having a high risk surgery and is over 45 is 41 over 190. Therefore, the events are not mutually exclusive. Now, how I have it here is how you're expected to indicate or to write it out in the exam or on your assignments. If the events are mutually exclusive, then the probability of a high risk surgery and over 45 will be equal to 0. However, the probability of high risk surgery and over 45 years is 41 over 190, which is not equal to 0. Therefore, the events are, or this implies rather, that the events are not mutually exclusive. All right. Conditional probability. The probability that an event will occur given that, let me say that again, the probability of an event B will occur given that the event A has occurred. This is referred to as conditional probability. And notice here it's denoted the probability that event B will occur given that event A has occurred. Now this is equal to the probability of A and B occurring at the same time over the probability of A. Now notice the event that has occurred, A here in this case, is our denominator. Okay, so the probability of both events, probability of A and B over the probability of the event that has occurred. Okay, and this little line would indicate given that, right? So it's the probability of event B given that A has occurred. And we're going to look on an example. What is the probability that a person who is under 16 years needs a high risk surgery? Now notice we are not selecting randomly selecting a patient as we did in the previous examples, right? Here, what is the probability that a person who is under 16 years needs a high risk surgery? All right, so we know that the person is under 16 years, so that's given. And we want to find the probability that they need a high risk surgery, right? So what we want to find is the probability of a high risk surgery given that the patient is less than 16 years. So it's the probability of having a high risk surgery and the patient is less than 16 years over the probability that the patient is less than 16 years. Probability of a high risk surgery and less than 16 years is 7, as you can see from the table, over 190. Probability that the patient is less than 16 years is 28 over 190. That works out to be 7 over 28. All right. We can also just simply look on it in terms of the simple probability, the number of favorable outcomes over the total number of possible outcomes. Because what's the probability that a person who is under 16 years? We're only interested in the patients who are under 16 years, right? And we have 28 of those. So our denominator would be 28. Of those 28, how many had a high risk surgery? And that was 7. 7 out of 28. All right. So any one of these would be a solution to this problem. And in the exam, a question like this would be worth about 3 marks. A medium risk surgery is to be done. What is the probability the patient needing it is at least 16 years. So again, this is conditional. We're told that a medium risk surgery is to be done. Okay, so that's a given. And we want to find the probability that the patient is at least 16 years. Okay, so again, I worked it out here both ways. probability the patient is at least 16, given that it's a medium risk surgery. The probability the patient is at least 16 and had a medium risk surgery over the probability of the patient having a medium risk surgery. Or you can think of it, you're only interested in medium risk surgery, of which there were 59, so that's our denominator. And of those 59, 46 of the patients were at least 16 years. That is 16 years or more. We're going to look on now to move on now to another rule, the multiplication rule. Okay. Now, a general rule for multiplication: when two or more events will occur at the same time and the events are dependent, then the general rule of multiplication law is used to find the joint probabilities. The probability of A and B is equal to the probability of A and the probability of B given A. Now, I'm going to use an example to illustrate what is really happening here. Okay, so we have an example. Suppose there are 10 marbles in a bag and 3 of these marbles are defective. Okay, now 2 marbles are selected, one after the other without replacement. So you're going to take one marble and then you're not going to put it back in the bag, and you're going to select another. What is the probability of selecting a defective marble followed by another defective marble? Okay, so you want to find the probability that the first marble is defective and the second marble is defective. Okay, so that's the probability that the first marble is defective, which is 3 out of 10, times the probability that the second marble is defective. Now, because you did not replace the previous marble, right? So it's the probability that the second marble is defective, given that the first marble was defective. Okay, so the probability that the second marble was defective would be 2 out of 9, because remember, you already selected one marble out which you didn't replace, so you now have 9 marbles, and the marble that you took out was defective, so you no longer have 3 defective marbles but 2, right? So the probability is going to be equal to 3 over 10 times 2 over 9. Okay, now this is when the events are dependent on each other. And we're going to look now on the multiplication rule when the events are independent of each other. And independent events, when the occurrence of one event does not affect the occurrence of another. Now, previously, the example that we looked on, because you did not replace the marble, it affected the probability of selecting the other marbles. Okay? But if you had replaced the marbles, selecting the second marble, it will be independent of what you chose before. Now, if the events are independent, then the probability of A and B is equal to the probability of A times the probability of B. Okay? If the events are independent, then the probability of A given B is equal to the probability of A. Remember, independent events, the occurrence of one has nothing to do with the other. So the probability of A occurring, given that B occurred, now B has nothing to do with A, so it will not affect the probability of A occurring. All right? So let's look on this example, or this question. Are low risk and under 16 years independent events? And you have to give reason for your answer. Okay, low risk surgery and under 16 years, are these independent events? Now, you have to not just say yes or no, you have to show, whether it's independent or not. And I have 2 ways in which you can do that. Now, if low risk surgery and under 16 years are independent, then according to the rule that we just looked on, the probability of A and B will be equal to the probability of A times the probability of B. That's the rule if the events are independent, right? So if these 2 events are independent, and the probability of a low risk times the probability of under 16 will be equal to the probability of low risk and under 16. So if the left hand side is equal to the right hand side, then they would be independent. Okay, now when we work out the probability of low risk and under 16, we got 8 over 190. When we worked out the right hand side, low risk surgery is 56 over 190 times under 16, 28 over 190. When we broke that down, we realized that the value on our left is not equal to the value on our right. Therefore, the events are not independent. Okay? Previously, I also said that if events are independent, the probability of A given B is equal to the probability of A. We can use that to show independence also. Using that method, let's look now. If independent, then the probability of low risk given under 16 will be equal to the probability of low risk. Now, the probability of low risk given 16 is 8 over 28. The probability of low risk is 56 over 190. These two are not equal to each other. Therefore, the events are not independent. So any one of these methods you can use to show. Now, two operations were randomly selected. Assuming independence, what is the probability that both were high risk? Okay, so two operations were selected. What's the probability that both were high risk? Okay, so we're looking for the probability that the first one is high risk and the second one is high risk. Now they are independent, so the first one has nothing to do with the second one. All right, so the probability of high risk, the first one being high risk, how many high risk surgeries are there? 75, so 75 over 190 times the second one is high risk. How many high risk surgeries were there? 75 over 190. And that would be your answer, whatever the product of that works out to be. Now, a similar question. Two operations were randomly selected, assuming independence. What the problem? Only one was high risk. Now, the sample space for this one, you're selecting two operations. Both could be high risk. One could be high, the other one medium. The first one could be high, the second one medium. First one could be high, the second one low. Next one, first one could be medium, second one high. We could have medium in both, low then high, medium then low, low then low. All right. We're looking for the probability that one was high risk. So therefore, which we will eliminate this one. So we can have high, medium, high, low, medium, high, low, high. So those three. Okay, so we have two with the low and high and two with medium and low. All right, so remember they are independent. So we can simplify the probability of having a high risk surgery and a low risk surgery and then multiply that by 2. Instead of working out high, low, and low, high, you can just, the answer would be the same for high, low, and low, high. Okay, you can work it out and you'll see. So the probability of a high risk is 75 over 190. Probability of a low risk is 56 over 190. Multiply that. Probability of a medium risk is 59 over 190. Probability of a high is 75 over 190 multiply. And then, of course, each of these you multiply by 2 because you have to consider if the first one was high and the second one was low, or if the first one was low and the second one was high. Okay? And then sum to get your answer. All right, so to summarize what we have discussed, the rule, the simple formula for probability. Probability of an event occurring is the number of favorable outcomes over the total number of possible outcomes. We also looked on the addition rule for finding the probability of one event or another event occurring. We also looked on the multiplication rule for independent events, the multiplication rule for dependent events, and the conditional probability.